So in this video, we're going to talk about solving quadratics, specifically the square root method, but this time we're going to introduce how you might have some imaginary or complex solutions. So quadratics actually always have two solutions. So sometimes those are two real solutions where it hits the x-axis twice, or maybe it looks like this and hits it twice. But what about a graph that looks like this? In the past, you've learned that this means there are no solutions. And the key here is actually there are no real number solutions. There are no real solutions. There are still two solutions. They're just imaginary. So if it doesn't hit the x-axis, that means it has two complex or imaginary solutions. And we'll have to find another way to find those. So this is true. There are no real solutions. They're just imaginary. This one's a little weird. It does kind of have one solution. It would just be repeated. So this one, let's say that was a -1. -1 would be the solution, but it would pop up twice. So it still has two solutions. It looks like one. So we could call that one solution if we wanted. All right, there are many ways to solve a quadratic. We've talked about these in the past. We're going to do square root method today, basically where you just square root and solve for x. You can factor it and set the factors equal to 0. You could graph and find the x-intercept, or if all else fails, quadratic formula always works. Remember, these solutions, like when you find x, these solutions are also called the x-intercepts because they are the x-intercepts. And they're also called the roots, and they're also called zeros because it's where the equation equals 0. So anytime you hear roots, zeros, x-intercepts, it all just means the solutions to that quadratic, what makes it equal 0. So for example, if I want to solve this, this one you can use the square root method. It only has an x squared, it doesn't have an x term, so I can get x by itself pretty easily. Just move all the things away from the x until you get it by itself. So subtract 28 from both sides. Then divide by 3. And then, to get rid of squared, you got to square root. Don't forget, when you square root, it could be plus or it could be minus. So we need to put a little plus minus there to represent two solutions. Here's where we get into something new. My answer is plus or minus the square root of -9, which is imaginary. The square root of 9 is 3, and because of the negative, I'll put an I here, because square root of -1. It's still plus and minus, and so that gives me my two imaginary solutions, positive 3i and then negative 3i. You can write it either way. And if I were to plug in 3i for x, I would get out 1. Also, if you were to graph this, it would not hit the x-axis. Let's try another one. This time I'll add 8 to both sides. So 4x plus 1 equals 8, then square root. Don't forget plus minus here. And also, 8 doesn't square root evenly, so I'm just going to leave it square root of 8. You could break it down to be 2 root of 2 if you wanted. Now that I have the squared gone, I can deal with this stuff. So I'm going to need to subtract 1 from both sides. Be careful because, well, first of all, those don't combine. This is a radical and this is not. So just leave them separate. The -1 can go in front or behind, it doesn't matter, but just leave it separate from the square root of 8. And then lastly, divide by 4. And so that's really all I can do with that one is get this. To be clear, this is not an imaginary solution. It's two real solutions. It's just they would be irrational because of the square root of 8. All right, let's try this one. On this one, we square root to get rid of the squared. Don't forget plus minus. And the square root of 9 is 3. Then I'll add 5 to both sides, but be careful here. It's tempting to be like, oh, so the answer is plus or minus 8. However, you really need to split it up because positive 3 and negative 3 are going to turn out different here. So if you ever keep going with the plus and minus, you need to split it into two separate things. Because positive 3 plus 5 is 8, but negative 3 plus 5 is 2. So those are my two answers here, 8 and 2. All right, let's try one more. Subtract 3 from both sides. Then divide by 9. And that doesn't come out even, so I'll just leave it, and then square root, plus minus. Here's the thing. I'm going to break this into pieces. First of all, square root of 30 and square root of 9 can be separated, and because of the negative, this is I, it's imaginary. Square root of 30 doesn't square root, it doesn't even break down by any perfect squares, but square root of 9 is just 3. So my final answer is plus or minus square root of 30 over 3i. The I goes on top, or it can go just kind of out to the side.